Hello everyone, welcome back to my channel. I have started a series of videos on data structures and algorithms. This series of videos will help you to understand data structures and algorithms easily. In my previous videos, I have discussed what is data structures, what are the types of data structures, what is the need of data structure, what is an algorithm, what is the need of an algorithm, what are the characteristics of an algorithm, what is time complexity, what is space complexity, what are asymptotic notations. All these topics were covered in details in my previous videos. The link of the videos are provided in the description box. You can check the link and watch those videos. Now let's start the video. In this video we will discuss about arrays. Now what is an array? An array is a collection of items of same data type stored at contiguous memory locations. It is one of the most popular and simple data structure and is often used to implement other data structures. Each item in an array is indexed starting with 0. It is a static data structure with fixed size. It combines data of similar types. As we have said, array is a collection of items of same data type. So that's why it is a collection of similar types. There are different operations possible in an array like searching, sorting, inserting, traversing, reversing and deleting. All these operations are performed in an array. How to represent an array? That means how array representation can be done. So the representation of array can be defined by its declaration. Now declaration means allocating memory for an array of a given size. For example, suppose if int array 5, array of 5, it means that it stores integer type element with maximum size of 5. Here int is the data type, array is the name of the array and 5 is the maximum size of the element. Or we can also represent as int array of 5 is equals to the number of elements that we want to assign to the array. So these elements are represented in memory in this form. 10, 20, 30, 40, 50 are the array elements. And array of 0 is these are the index number. Array of 0, array of 1, array of 2, array of 3, array of 4 is the index number. These are the indexes, these are the elements. As we have considered 5 is the maximum size, so 5 elements we have taken here. And we have already mentioned earlier that the first index of an array always starts with a 0. So this is an example of a linear array. An array is divided into two types. One is a linear array, another is a multidimensional array. So this is an example of a linear array we have discussed now. Next topic is what is multidimensional array? Now a multidimensional array can be termed as an array of arrays that stores homogeneous data in tabular form. The general form of declaring n-dimensional array is shown below. So this is the syntax of the multidimensional array. There is data type, then array name, size 1, size 2 up to size n. For example, int array 10, 20. This is an example of a two-dimensional array. Int array 10, 20, 30. This is an example of a three-dimensional array. Here 10, 20 are the size of the dimension. 10, 20, 30 are the size of the dimensions. For three-dimensional array, three dimensions we have used. For two-dimensional arrays we have used. That is 10 stands for rows in two-dimensional array and 20 stands for columns. Now the total number of elements that can be stored in a multidimensional array can be calculated by multiplying the size of all the dimensions. Which means that for two-dimensional array, if m is the number of rows and n is the number of column, then the size of the dimension will be m into n. Here for example, for int array 10, 20, the maximum element that we can consider is 10 into 20 is equals to 200 for two-dimensional arrays. And for three-dimensional array, we can consider 10 into 20 into 30. That is 3 to the 6, 6,000 elements is the maximum elements that we can consider for the three-dimensional arrays. Next is what are the advantages of an array? The first advantage is efficient access to elements. That means array provide direct and efficient access to any element in an array with the help of an index number. Next advantage is fast data retrieval. Array allows for fast data retrieval because the data is stored in contiguous memory location. This means that the data can be accessed quickly and efficiently without the need for complex data structures or algorithms. Next advantage is memory efficiency. It stores data efficiently in memory as it stores multiple data of similar types with the same names. Arrays are also memory efficient because the elements of an array are stored in contiguous memory location. The size of the array is known at the compile time. This means that memory can be allocated for the entire array in one block, reducing memory fragmentation. Next advantage is easy to implement. Arrays are easy to implement and understand, making them an ideal choice for beginners learning computer programming. Next advantage is versatility. Arrays can be used to store a wide range of data types, including integers, floating point numbers, characters, and even complex data structures such as objects and pointers. The next topic is what are the disadvantages of an array. The first disadvantage is fixed size. Arrays have a fixed size that is determined at the time of creation. This means that if the size of the array needs to be increased, a new array must be created and the data must be copied from the old array to the new array, which can be time consuming and memory intensive. Next disadvantage is memory allocation issue. Allocating a large array can be problematic, particularly in systems with limited memory. If the size of the array is too large, the system may run out of memory, which can cause the program to crash. Next disadvantage is insertion and deletion issues. Inserting or deleting an element from an array can be inefficient and time consuming because all the elements after the insertion or deletion point must be shifted to accommodate the change. Next disadvantage is wasted space. If an array is not fully utilized, there can be wasted space in the memory allocated for the array. This can be a concern if the memory is limited. And the last disadvantage is lack of flexibility. The fixed size and limited support for complex data types can make arrays inflexible compared to the other data structures like linked list and trees. Next topic is what are the applications of an array in data structure. The first application is storing and accessing data. Arrays are used to store and retrieve data in a specific order. For example, an array can be used to store the scores of a group of students or the temperatures recorded by a weather station. Next application is sorting. Arrays can be used to sort data in ascending or descending order. Sorting algorithms such as bubble sort, merge sort, insertion sort, selection sort, quick sort rely heavily on arrays. Next application is searching. Arrays can be searched for specific elements using algorithms such as linear search and binary search. Next application is matrices. Arrays are used to represent matrices in mathematical computation such as matrix multiplication, linear algebra, image processing. Next application is stacks and queues. Arrays are used as the underlying data structure for implementing stacks and queues, which are commonly used in algorithm and data structures. And finally, the last application is graph. Arrays can be used to represent graphs in computer science. Each element in the array represents a node in the graph, and the relationship between the nodes are represented by the values stored in the array. Thank you everyone for watching the video till the end. Like, share and subscribe for more videos.